So we have this problem from one of the official SAT practice tests. In the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b? Now, at first looking at this, a lot might be a little confused because they don't really know how to even go about approaching a problem like this. But the key is knowing what it exactly means for a quadratic equation to have no solution. So what's important to note here is that there's one part of the quadratic equation which actually determines how many solutions a quadratic formula or a quadratic equation has. So in the quadratic formula, we if you remember, is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. My B's are not very good with this writing pad, but hopefully, I mean, you know the quadratic formula, so this should hopefully be just review. Now, there's one part of this that's important to know that determines the number of solutions, and that's this part right here under the square root. This is called the determinant, as it determines how many solutions the system of equations will have, or the quadratic equation will have, excuse me. So we're going to look at that part exclusively. So b squared minus 4ac. And now obviously these letters are coming from the coefficients of these variables. A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So it's pretty clear to see why this part would determine how many solutions it has, because this is the part we're adding or subtracting. So if this comes out to 0, we'll only have one solution. If this comes out to a positive number, we'll have two solutions for the plus or minus whatever value this comes out to be. And the case where this has no real solutions is where this is negative, right? Because then the square root will be of a negative number, and that would produce a not real number. So we're looking at b squared minus 4. And now we have AC. So A, the coefficient is -1. And for C, the coefficient, or the constant is just valued to be -676. So now in the new SAT, you'll have a calculator to access for any of these. So you won't need to know how to do this. I mean, you won't have to waste time doing a paper and pencil. But what this comes out to be is 2,704. So now we want to find the nearest value of b, or the highest value of b for which this would still be negative. So basically, what's the biggest value of b such that b squared is smaller than 2,704? Now, you can use your calculator again to just find the square root of this number, which is 52, right? So then you might want to say, oh, b is 52, we're done. But that's not quite the case, because when b is 52, then our determinant is 2,704 minus 2,704, which is 0. So then this becomes 0, and that would give us a real solution to our equation, since square root of 0 is a real number. So instead, b needs to be just a little smaller. In this case, the next smallest integer, which is 51, because then this number will be less than 2,704, and we'll get a negative number for the determinant. So that's just a long way to say our answer for this question is b equals 51.